Here's midterm 1 for spring 2025, CS 159. Starting with questions 1 and 2. Every time I see a code segment, I always kind of scan through it before I get started. So in this case, I see we have all integers, and then we have some math going on. We're going to print it with a variable width because of the asterisk. So the width is going to be a, and then we're going to print out the value of a plus b plus c. We'll update c and then print out that. So jumping in to start solving the code, right, c is going to equal the square root of a times a, so 7 times 7 is 49, plus b times b, 5 times 5 is 25, that's going to be 74. Well, the square root of 74 is going to be some complicated decimal, right? You're not expected to know that, but you do need to solve this problem. Well, if you think about it, c is an integer, so we don't care what comes after the decimal point. So if 74 is between 64 and 81, we know that the square root of 74 is between 9 and 8. So int c equals 8 point something something something. Well, that right-hand side is going to be converted to an integer to match the left-hand side. We get rid of the decimal, we truncate, round down, however you like to think about it. So c is equal to 8. Now here we have it being printed out. So a plus b plus c, 7 plus 5 plus 8 is going to be 20. A is 7, so our width is going to be 7, represented by this asterisk right there. Some other things to notice, we have a hard-coded space. So looking at my answer choices, I'm going to mark that hard-coded space in all of them first. Then I'm going to draw a line immediately after it. And I'm going to count my 7 spaces that I just reserved and draw a line on the other side. Well, I know that without any additional formatting flags, this number should print to the right of the width that's being reserved. So the number should be inside the 2 lines, but all the way to the right, which means that C is the correct answer choice. Then moving on to question 2, we have C is equal to A times 10, 7 times 10 is 70, plus B times 2, 5 times 2 is 10. So our answer is going to be C is equal to 80. Now something to note, here we have a %C. So the result is not going to be 80, it's going to be the character represented by the value 80. So what you should do is go to your ASCII table. In this case, you're going to see that it's not a number, and obviously it couldn't be any of the answer choices because you can only print a single character. So therefore the answer is D, none of the above. Question 3. In the Chapter 1 recordings, you're introduced to the simplified model of the memory hierarchy. So remember, we have this idea of speed as you go up the pyramid, and then as you go down the pyramid, you get more capacity at the widest point. So, which of these is false? A, the level of memory closest to the processor can be accessed the fastest but has the smallest capacity of all levels present. So remember, that's going to be close to our processor. We have the registers, for example. Those you can only hold, a small set of numbers, but you can do really fast computation with them. So it can be accessed the fastest, but the smallest capacity, because it's at the very top. A is true. B, the secondary memory level is the slowest to access data and instructions due to their large capacity, with many of these being mechanical components. Something like your hard drive, right? It could even be a spinning disk inside, right? And so that spinning, you have to go search for the value. It's slow to find, but you can buy gigabytes, even terabytes for, a very affordable price. And that's its advantage. So B is going to be true as well. C. Main memory is a place where data and instructions are temporarily stored during processing. So main memory is going to be like your RAM. So when you want to run a program, you're going to pull it out of your secondary memory, put it in main memory so you can fairly quickly access whatever you need. And then for the actual computation, you bring it up to the registers. But main memory is going to be the place where they're stored temporarily during processing. That's true. Then we go to D, none of the above. Now question 4 asks about the idea of a programming language being classified as high or low level. Remember that we consider C to be a high level language. Which of the following statements related to this idea is true? So A, a high level language allows the programmer to concentrate on the problem at hand and not worry about the specific machine that the program will be using. So this is going to be true. So whether you want to think of C or some other, modern language, Python, whatever, you can write your lab code, your homework code, whatever, your .c file, send me that .c file, and I should have no problem compiling it and running it on my own device. So therefore A is true. B, a low-level language will use natural language elements that makes them easier to use, understand, and develop. So this will be false. So when it talks about natural language elements, that means, it's terms that make sense if they were just in a book or, written in English. So do, while, for, print, scan. These are all words that we already use, and you can kind of guess what they do without even knowing code. Low-level languages, something like assembly, does not write in this way, right? You write more in the style of the computer's actual interpretation. So B is false. C, the task of managing memory is the responsibility of the programmer when using a high-level programming language. This one is going to be false as well. So when we want to create a variable, all we do is we just declare that it exists. We don't have to go looking through memory for an available segment to reserve for that value. So our answer is A. So moving on to questions 5 and 6. As always, I like to kind of scan through my code first. I see here we have a mixture of integers and doubles. The update C, we're going to print it out with a variable precision. So the precision is going to be represented by variable B. Update it again. And then we're going to print out with a new flag we haven't seen before this time. So diving right into our code, we have C is equal to A divided by B. Well, we have 11 divided by 4. Integer divided by integer is going to be integer, so there's no space to hold that decimal, that 0.75. So this is going to be equal to 2. So now our right-hand side is 2, the left-hand side is a double, so we're going to promote 2 to 2.0 to match. So C is equal to 2.0. So we're going to print out the value 2.0 with a precision of 4, meaning 4 values after the decimal point. So our answer for 5 is going to be C. Moving on to question 6. C is equal to A mod B. 11 mod 4 is going to be 3, because that's the remainder after you get that. So 11 divided by 4, 2 with the remainder of 3. Then we have this flag right here. The minus sign means we're going to print it to the left of the reserved space. So we are reserving 5 spaces, printing 1 decimal, and we also have this hard-coded space right here. So what I'm going to do is first mark my hard-coded spaces, and draw my left line of where I'm going to reserve space. Then, 5 characters later, I draw my right line. And I know that because of that minus sign, that flag, I'm going to print it to the left. So therefore B looks like my correct answer. And just to confirm, there's 1 hard-coded space after, so that matches. Moving on to questions 7. Which of the following statements does not represent a course standard or programming standard of the course? So A, all declaration of variables must occur before the start of the executable statements in a given function. So if we have something like this code right here. Right, this would not be permitted in this course. Right, we do not allow the mixture of declarations with executable statements. All of them need to occur before. So int c needs to be moved up to be declared int B, int C. So A is a programming standard. B, to avoid any potential use of a variable storing an unknown value, it is a standard to ensure every variable is initialized in its declaration statement. So our code that we're writing out might look like this. And this is totally okay. Here, we don't give x an initial value because we're going to explicitly give a value later on down here. So there's no requirement to set x to 0 or some other value when you declare it. So B is our answer. C, variable declarations are to be placed inside of a function as local variables and are not permitted to be declared globally. This is going to be true. This course does not permit global variables. So any information you want to pass between functions needs to be within the parameters and the return statements. Question 8. Which of the following statements regarding the scanf function is true? A, the two components of a scanf function are the format string and the data list. So this is a really tricky one. Remember what our scanf looks like. So if we want to scan in an integer, here we have the format string and then the address list. This is not a data list. So the data list is part of the printf call. Printf, you have the format string and the data list. Scanf, you have the format string and the address list. B, a single scanf function call can be designed to accept an input of multiple values. This one is going to be true. So let's say you want the user to enter a coordinate pair. Your scanf call might look something like this. So you can have multiple, percent flags, multiple values on the same line. If you want them to type it with formatting, like the parentheses and a comma, you can throw that in too as well. So B is going to be true. C, the conversion codes used for placeholders with integers, floating point values, and character data are not the same in the scanf as the printf function. So this is false. So scanf and printf both use %d for integer, %c for characters, %f for float, all the rest are identical. So our answer for 8 is B. So moving on to question 9 through 11. Again, I'm going to kind of look through my code first. I see we have some defined constants. We have a mixture of integers and floats, and then some calculations below. So something to note before we jump in with our defined constants. So remember that these constants, their text after, gets substituted below where we use it. It doesn't mean that we resolve it down 2 divided by 3 is equal to 0 before we substitute. So, question 9, which is the first line of output. Well, we're going to print out area. So area is going to be mpi, which is approximately 3.14, times circle, so times 1 divided by 3. There's no parentheses or anything like that here, times radius squared. So 3.14 times 1 is 3.14. 3.14 divided by 3 is roughly 1.04. 1.04 times 9.0 is roughly 9.36. We're going to only print to one decimal place, so it looks like B is our correct answer. Once again, note that we did not resolve this down to 0 before calculating our full equation. All right, now we're going to look for volume. So volume is going to be hemisphere 2 divided by 3 times radius cubed, 327.0 times m pi, approximately 3.14. So again, we have all these operators are the same precedence, so we read it left to right. So 2 divided by 3, an integer divided by a larger integer is always going to be 0. So 0 times all that is going to be 0. So our answer for 10 is A. Then for question 11, we have 3 times hemisphere, 2 divided by 3 times m pi times radius squared. Well, we have 3 times 2 is 6. 6 divided by 3 is 2. 2 times 3.14 is 6.28. And 6.28 times 9.0 is going to be roughly 55, 56. We'll call it 56. Looking at our answer choices, looks like B is our correct answer. Question 12. Which of the following statements regarding symbolic or defined constants is false? A. It is a core standard to make use of the symbolic and defined constants only when their use will reduce the amount of code present in a program. Well, this is going to be false. So in this course, we usually use defined constants to represent, single values, a coefficient of an equation, maybe a unit conversion, right? These are numbers that we want to keep a certain precision consistent throughout, and then we might want to go back and update later on to change. So we're not reducing the code, we're just making it more maintainable in the future. B. The data type of values represented by symbolic and defined constants must be considered when evaluating an expression. So this one is going to be true. So if we have something like above, right, we need to look at 2 divided by 3 is going to be integer divided by integer. Here we have integer and integer again, right? And so we have to consider how it interacts with the values around it. So B is true. C. A variable can be updated through the use of the assignment operator, but the value associated with a symbolic or defined constant is not established through the use of the assignment operator. So if we have something like pi is 3.14, we cannot update it, but we also don't declare it with an equal sign. So something like pi equals 3.14, right, would not work. That's not permitted. Moving on to questions 13 and 14. Here we have the use of the prefix and postfix operator. So this really is a test of how well you can organize your work. So just as a reminder, for prefix, and postfix, right, we have plus plus x, x plus plus. So for this one, we're going to update first, use the new value. Well, postfix means solve the equation first, then update the value, or the variable, I should say. So looking at our code here, we have x plus equals, so I like to rewrite this compound assignment as x is equal to x plus in parentheses. Y plus plus is postfix, so we're going to use the current value, which is 10, minus z, so we're going to update first, use the new value, and I should also substitute in the value of x. So 13 plus 10 minus 15, 13 plus negative 5 is going to be 8. And then now we're going to look at our postfix increment or decrement. So now we're going to update y. And then we can move on to the next line. X equals the current value of x times minus z, so update first, modulus plus plus y, so update first. 14 mod 12 is 2. 8 times 2 is 16. There's no postfix, increment, or decrement in this line of code, so we can move on to the next one. X is equal to the current value of x minus z, so update first, minus y plus plus, so we can use the current value. X is equal to 16 minus 13 minus 12, 16 minus 1, x is going to be 15. Before we move on to the next line, we have to do our postfix increment of y. Then finally, z is equal to the current value of z, 13, divided by plus plus x, update first, minus y minus minus, use the current value, 13 divided by 16 minus 13, 13 divided by 3, integer divided by integer results in an integer, so 13 divided by 3 is going to be 4. Then we're going to update y because it's postfix. So our final answer is going to be x is 16, y is 12, and z is 4. So 13 is A, 14 is B. Question 15. Which of the following statements regarding prefix and postfix operators is false? A. The operand for a prefix or postfix operator may be a variable or constant. So we can't do something like plus plus 1, 2, 3, right? 123 is a constant number. It's not something we can change. It's not mutable. It's not a variable. So this is going to be false. Obviously, a variable is totally okay. B. The same variable cannot serve as an operand for both a prefix and postfix operator in the same arithmetic expression. So we can't do something like A is equal to plus plus B plus B plus plus. Right? This is undefined behavior. There's some unknown as to the order of which updates should happen and which values should be used. So it's not permitted or will not work to use the same variable twice if it's going to be incremented or decremented. C. When used in a statement without any other operator, a postfix increment operator can be changed to a prefix increment operator without changing the behavior of the program. So if we have x is equal to 3, x plus plus, print x, right, we're going to print out 4. If we did this instead, we're still going to print out 4 because it's in a separate line. If the increment or decrement happen inside the print statement, then it is possible that the behavior would change. But in this setup, as the answer choice describes, right, it's on its own line. It can't change the behavior. So A is our answer for 15. Question 16. Which of the following statements regarding data type conversions is false? A. An implicit type conversion will always promote a lower ranked data type to that of a higher ranked data type. So remember, our implicit is something like, let's say A is equal to 2 times 3.14. Right, so 2 times 3.14, we have an integer times a float or double. We'll just call it a double in this case. And so for this multiplication to occur, the types need to match. So 2 is going to be promoted to 2.0. So we have 2.0 times 3.14 is 6.28. For implicit type conversion, you're never going to demote because we don't want to lose that detail, as I like to think of it, in our math. So A is going to be true. B, an explicit type conversion is insufficient to alter the type of data that can be stored in the memory of the variable to which it has been applied. So remember, the type of data that can be stored, one of the things that determines this is the amount of memory that's been reserved for the variable, as well as some other things such as how it's actually stored. But anyways, if we have something like double x equals 3.14, then later on we say x is equal to int x. Well, what does this do? So it says take the value stored in x, 3.14, convert it to an integer. So now the right-hand side is 3. The left-hand side is a double, so the right-hand side gets promoted to 3.0. So x is equal to 3.0. So we did change the value, but the type of data that's stored is still a double. So therefore, B is going to be true as well. C, assignment conversions are not considered to be implicit type conversions because of the potential for the conversion of the higher ranked type to that of the lower ranked type. So this one's going to be true as well. So if we have int x is equal to 3.14, right, 3.14 is a double, but we have to make the right hand side match the left hand side. So we're going to demote 3.14 to be integer, or 3. So therefore answer is D, none of the above. Question 17. Which of the following statements regarding user-defined functions is true? A. The order in which instructions are executed in a program can be altered through the use of the function calls. So this one is going to be true. So let's say our program is going to ask the user for, let's say they're going to ask for a height. And then we're going to also ask for a mass. Well, if we read our code and we see actually the expected output wants us to ask for mass first, all we have to do is swap the order of our function calls. Now we're going to see the prompt for mass first before wait. All we did is we changed the order of function calls. B, the order in which functions are called in a program must match the order in which they're declared in the global declaration section. So remember, we declared them up at the top above the main function, but there's no need for the order to match, just like there's no limit on how many times we call these functions. So B is going to be false. C, the order in which functions are declared in a program must match the order in which they are defined following the main function. Once again, there's no requirement you can do it all in any order as long as declarations are above main and definitions are below main. So therefore, answer for 17 is A. All right, here we have questions 18 and 19 asking about this code segment. Briefly scanning through it, we see some defined constants, some unit conversions. We have a user input. We have something that kind of looks like our selection by calculation, kind of that behind the scenes logic, and then the actual, selection occurring down there. So kind of running through our code really quickly, right, we see, so we have a user input, then here we have option equals 0 if quantity is less than minimum. Great, because that's integer division. Option is equal to 1 or greater, because it could be a multiple of minimum, if quantity is greater than or equal to min. So that was this line right here. What about the line underneath? Hopefully you recognize this equation. If not, right, here's something to kind of memorize, I would recommend. So you have x plus 2 mod x plus 1. Right, if our input is 0, 2 mod 1 is going to be 0, right? Any number mod 1 will be 0. If our input is 1, 2, 3, 4, whatever, right, you're always going to have a number modulus a number that's 1 smaller, so your the result is going to be 1. So anything 1 or greater. And now you can see, oh, well, this actually lines up with our previous line. So if option is equal to 0, if quantity is less than minimum, then we make this transformation, 0 stays as 0. If option is 1 or greater, depending on how much greater quantity is than minimum, well, we're going to scale it down to 1 no matter what. So no matter if it's, even if quantity is 5 times minimum, and this is 5, after this equation, it's going to be 1. So what I can do is I can take out this 1 plus. So now these two lines are represented by this logic right here. Then looking at the next pair of lines, here we have quantity times 2 kilogram times option. So If option is 0, then this all gets eliminated. If option is 1, then we make that transformation. So if option is 1, meaning if quantity is greater than or equal to minimum, quantity times equals 2 kilogram. Else here we have if option is 0, or if quantity is less than min, quantity times equals 2 pounds. All right, so at this point, I reduced all this code down to this logic right here. So now we actually can solve this problem. So first our input is 19. Well, let's look at this. 19 is our quantity, minimum is 25. 19 is less than 25, therefore we do quantity times equals 2 pounds, or 2.205. 19 times 2 is 38. 19 times 2.2, maybe 40, 41 as a rough estimate. Looking at our actual answer choices, it looks like A is our correct answer. Then moving on to question 19. So which of these inputs, if given, would result in 42.2? Well, now that we've reduced our logic down to this, we can actually just try the answer choices pretty fast. So if quantity is less than minimum, 22 is less than minimum, quantity, 22 times equals 2 pounds. 22 times 2.2 is going to be a little bit more than 44, maybe 46, 47, which is not our result, so it can't be A. Then looking at B, quantity is greater than or equal to minimum, 93 is greater than or equal to 25. 93 times 0.454 is going to be roughly 42, right? Because if it was 100 times that, we'd have 45. 93 times that, I think is probably pretty close to 42.2. So it looks like 93 is our correct answer. Looking at C, 20 is less than minimum, 20 is less than 25. 20 times equals 2.205 will get us, again, about 44, maybe a little bit more, so that can't be our answer. So therefore my answer for 19 is going to be B. Notice how for both 18 and 19, I didn't actually go step by step through the code. Especially kind of looking ahead and seeing the way that 19 asked the question, it's better to look at your program, reduce it down to some kind of more English translations of the code, and then you can run through these different inputs very quickly. Question 20. Which of the following statements regarding user-defined functions is true? A variable declared in the local declaration section of a function can have the same identifier as one of the parameters of the same function. So this one is going to be false. That's saying if we have something like some function that we pass in, say it gets the height, we can't have another height variable down here, right? Because these have the same scope. So height has the scope of this function, and now this local variable, local declaration, right, has the same scope all the way down to the bottom of the function. And so now they're conflicting, and so if you want to talk about height, you don't know which one you're referencing. B, parameters being received by a function will be commented to the right of which they are defined. So remember, parameters are things, right, in that first line. Well, let's say we're giving the height, the weight, the width, the length, all sorts of different parameters. We get a really long list. And that means you'd have a really long comment to the right because it's all in one line. That's why we use the function header. Remember, the function header is something, it has the name of the function, it has the parameters, the return type, and the description, right? So you're going to insert that above every user-defined function. So therefore, you don't comment it to the right, right? This is the alternative to make it more organized. So per course standards, B is going to be false. C, a local variable cannot be referenced through its identifier outside of the function in which it is defined. Well, this is going to be true. So this is saying I can't use the term height in my main function or another user-defined function, right, to reference this variable here. Now I can pass it
a parameter I can pass by address. I can have my own variable called height in another user-defined function. But to reference this spot in memory, right, I can't do it by just using the term height somewhere else. So C is our answer. Question 21. Which of the following statements regarding the UDFs is false? A. Restricting a function to accomplish only a single task will increase its potential for reuse. So this one's going to be true. Right, so if we, for example, a favorite one of students in this course is to combine input functions. So, maybe this task we want to ask for, the height and the length of a box that we're putting something in, for example. Well, it's possible in the future we might say that one of those values is a given, it's a constant, and so we only want to prompt the user for one value. Well, now we have to go back and edit our function to make it only prompt for one. Whereas if we make one input, request one piece of information per function, all we have to do is remove a function call. We don't have to actually edit the code inside each function. So A is going to be true. We really want to design our program so that we could change the purpose by only changing the defined constants in the main function. B, one benefit of user-defined functions is the potential reduction or elimination of duplicate code. This is going to be true as well. So if your program, multiple times throughout, maybe the main function needs it, some of your user-defined functions need to know, for example, if it's a leap year or not, right? You don't want to keep writing that same long expression out, checking if it's a multiple 400, 400, all that, right, every single time. One, it's duplicate code, and so you have to keep writing it out. But two, it's really hard to debug. Or maybe you change the formula you use, and now you have to go search for all the other places you used it as well. So B is going to be true as well. C, a function should be designed such that it is testable apart from the rest of the program. This is going to be true as well. So this is kind of the idea, there's ideas of test-driven development, things like that. But really, what it's saying is that every time you add a new task to your program, you add a new function, you should be able to add that function call to main and just say, hey, does it work up to this point? Maybe you need a printf to verify something like that. But basically, you should be able to test along the way every time you add a new function, whether it is working, or even in isolation, right? So your input function doesn't require an output function or a calculation function to test. Because it's one single task, you just verify that it changed the value with a print statement. So therefore, answer is D, none of the above. All A, B, and C are true. All right, here we have questions 22 and 23. So looking through our code, we have some stuff going on with chars. You can see when we printed out there with %C, it looks like some selection by calculation down here and some other calculations as well. And then looking at our program or our questions, they're going to ask for those two lines of output. So looking at these specific functions, print data, all it does is it just makes sure that we're not printing in main, but it's just going to print that character out. We can verify it has the %C. Then print punctuation is going to choose between these different symbols. So I always like to kind of translate things into more English terms before I jump in rather than trying to solve out the code for each question, even for cases like this where there's only two questions attached. So looking at our code, we have nmod2. Well, we know that nmod2 is going to return 1, or true, if odd, and 0 if even. So out equals that if even. Excuse me, if odd, because it's going to be 1 times that. Then out plus equals, well, 1 minus nmod2, so we're basically flipping it. So now, instead of if odd, it's if even. Well, in this case, right now we have this plus equals, but we know that every number is either odd or even. So it can't fall under both cases, so we can't add a dash and an exclamation mark together in this case. So I can get rid of this plus equals, because I know that's going to fall underneath one of those two cases. And then out plus equals n divided by 3, integer division. And then we return, or we print out. So jumping into our actual code, we can see that our parameter is going to be, well, first we print out C, then we're going to print punctuation for 2. Well, let's look at our choices. So 2 is even, so exclamation point, and then out plus equals 2 divided by 3, integer division. It's going to be plus equals 0. So we're going to print out an exclamation point. And then we're going to print out B. So for 22, my answer is A. Moving on to question 23. Here we have print out punctuation of 1, print out A, print out punctuation of 3. Looking at this, right, for input is 1. 1 is odd, so we have a dash. It's not even, and then out plus equals 1 divided by 3, which is 0. So we're going to print out a dash. We're going to print out that A, and then we're going to print punctuation 3. Well, 3 is odd, so we have a dash. 3 is not even, so ignore the exclamation point. And then out plus equals 3 divided by 3, so out plus equals 1. So now we have dash plus 1. And this is when you need to go to the ASCII table in the back of your exam. So looking at the ASCII table right now, I can see that dash or minus sign corresponds to a value, a decimal value of 45. If we do 45 plus 1 is 46, the character that corresponds to 46 is a period. So my answer is going to be, let's see, looks like it's going to be none of the above. I'm printing out dash A period. Moving on to question 24 and 25. Previewing through this code, right, I see I have a couple of function calls, I have some nested function calls, and just a single line of calculation. So, in a case like this, sometimes you just may decide it's easier to jump straight into the code and solve it, rather than kind of translating this equation. In this case, I don't really see a pattern that's clear to me, so I'm just going to jump right in. So we're looking at the first line of output. So what is the result of this? So x is equal to 10, y is equal to 4. So we're going to return 10 minus 10 divided by 4 times 4. Well, of course, we have to remember precedence. In this case, it's, the same order of operations you learned in a math class. So we start with 10 divided by 4, integer divided by integer. That's going to be 2. We ignore the 0.5. 2 divided by 4 is going to be 8. 10 minus 8 is going to be 2. So result number 1 is going to be 2. Moving on to question 25. Notice here we have nested function calls. So first I'm going to do this inside call, and then I'm going to work my way out. So x is equal to 30. Y is equal to 8. 30 minus 30 divided by 8 times 8. So again, like before, remember order of operations. An easy trick is to think that these cancel out, but they don't because of the way this equation and the way that we resolve math in the C language works. So 30 divided by 8 is going to be 3. We ignore the 0.75. 3 times 8 is going to be 24. 30 minus 24 is going to be 6. So now this resolves to 6. And we use that 6 as one of the parameters for our next function call. So now for this larger call, my parameters are going to be 5, x equals 5, comma, y equals 6. 5 minus 5 divided by 6 times 6. Remember, small integer divided by larger integer is going to be 0. 0 times 6 is 0. 5 minus 0 is 5. So my answer for 25 is going to be C. Result is 5. Moving on to question 26. So which of the following statements correctly identifies what is being referenced when a user-defined function is classified by a data type? So remember, if we have something like maybe it's an input function, for example. We say int get, say get size. Probably no parameters, so put void, and something happens inside. Print, scan, return size. So what is being referenced when we talk about a data type? Well, when we're talking about a data type, we're talking about what is being returned, right? Because that's what we care about. And the main function or whatever function is calling it just cares about what's being returned. So we're returning size, and from here we know that size is an integer. So looking at our answer choices, A is going to reference the type of value being returned. B is about what's being passed. Well, in this case, we pass nothing, it's void, right? So we're not talking about what's being passed. C, the references the variables declared inside the function. Well, you can declare other things inside. In this case, we probably only declared it in size, but you might also need to, maybe you do some calculation or something with a float, or maybe this is not an input function. You have other variables involved, right? So our answer is A. We just care about what is being returned, which is represented by this term right here. Moving on to question 27. Which of the following regarding data types is false? A, the amount of memory necessary to allocate to a variable depends on its data type. This is going to be true. So certain data types require more data than others, right? A char has a very small set range of values, whereas a long, has huge, billions of possible values. If you want to go from a float to a double, you have to double the amount of space and memory that you're allocating for it. So A is going to be true. B, the range of values that can be represented by a variable depends on its data type. So like I just said, right, a char, just a few hundred values. Long, you might be going in the billions of values. So B is going to be true as well. C, the possible operators that can be applied to a variable depends on its data type. This is going to be true as well. It's a little trickier, but remember that you can't use, so we have these kind of main operators. Your plus, minus, times, divide, right? Those ones you can put on any sort of data type. But we also have this fifth one we've talked about, modulus. So modulus, integer family only. So you can use modulus on integers, of course. You can use it on chars, longs, long, anything like that. But you can't use it on the float family. So if you use a float or a double, right, you're going to get a warning or an error when you try to run your code. So C is true as well. Therefore, answer is going to be D, none of the above. Questions 28 through 30. Looking at our code right here, we have some stuff going on that looks like maybe has to do with some rounding, right? We're changing data, or explicit casting, I should say. Here, we have some other stuff with 0.4, which is making me think like we're trying to kind of go over a little bit to round an integer, right? Because we have integers up here. We have some different stuff going on here with integer division, order operations maybe, right? So I don't really know what this code is going to do yet, but I just kind of look for patterns or things that surprise me. All right, so I usually don't see a plus 0.4 anywhere in the code. So I'm just going to be very careful when I solve this out. So this is one where, again, I'm just going to kind of dive right in because we don't reuse the same code multiple times like we do with a function problem. So first line of output, int c. As a reminder, I'm going to write integer right there. C is equal to integer a, which is 4, divided by 2. 4 divided by 2 is 2, times 2, integer 2, or integer b. So 4 divided by 2, that's going to be 2. Pretty easy problem, right? Then moving on, we have c is equal to a plus 0.4. Well, integer 4 plus 0.4 is going to be double 4.4 times integer b. So 4.4 times 2 is going to be 8.8. But remember that c is an integer. So now c is equal to 8. But then here we cast explicitly c to a float. So do we keep the 0.8? Well, the 0.8 was already thrown away up here, right? There was nowhere to put the 0.8. We had to throw it away to make the right-hand side match the left-hand side, or make the double on the right-hand side match the integer on the left-hand side. So that 0.8's been totally forgotten about. So in this case, we just print out 8.0, right? There's nowhere that 0.8 was held onto. Moving on to question 30, we have integer c is equal to a, which is 4, times b casted to a float, which is 2.0, divided by a, which is 4, times b, which is 2. So 4 times 2.0 is going to be 8.0. 8.0 divided by 4 is going to be 2.0. 2.0 divided by 2, or times 2 is going to be 4.0. Remember that c is an integer. 4.0 is a double. So we're going to make the right-hand side match the left-hand side. So c is equal to 4. Then here we're going to print out a float, and our float's going to be c plus 0.1. So 4 plus 0.1 is going to be 4.1. So again, this problem is just a case of being very careful about data types, right? It's okay to mix into our doubles and our integers. We just need to be careful about doing the order of operations correctly. Question 31. Which of the following statements regarding the waterfall model of software development is false? A. Writing code is the first step in the waterfall model of developing software. This one is going to be false. So remember, our first step is our requirement gathering analysis. We have some other steps before we actually create the code. Creating code should be near the end. Think of all the things you do when you first get an assignment. Hopefully you're creating a flow chart. You're discussing the problem with your group, right? What are the things I need to solve? What is the data that you need to, complete those equations? And then at the end, we want to test and update and all that as well. So writing code is somewhere in the middle, a little closer to the end of that model. If you don't remember this model, you can review your chapter 1 recordings. B, the waterfall model of developing software places an emphasis on planning and testing. Well, like I just said, there's a lot of steps that come before you actually create your code. And then once you do create your code, you're going to test and update and maintain it, right? So that's true. C, the final step of maintenance in the waterfall model includes potential future modifications. And if the previous steps are done well, then maintenance should be easier. Again, that's exactly how it works. So if you correctly identify what data you need and what you need to calculate, right, you're probably not going to have as many bugs. If you develop it carefully and test along the way, right, you're going to catch those issues earlier on before they kind of get hidden behind all the other logic and the other functions. So C is going to be true as well. Our answer is A. Question 32. Which of the following regarding the preprocessor is false? A. The preprocessor is a part of the compiling process and can be used to prepare code for the remainder of that process. That's going to be true. So anything like including a library, hash-defined constants, any of those things at the very top of your program, right? You're saying, I have all this text, this library set of code, you have a defined constant number or macro, whatever it is, right? You're going to take that code and substitute it everywhere below, kind of like a copy and paste, before you actually try to compile the code. So when the compiler goes through and compiles your code, right, it's going to see 3.14. It's not going to see pi, anything like that it doesn't recognize. So A is going to be true. B, a defined constant is a preprocessor directive that results in the substitution of the value that follows the symbol everywhere it is found in that program. So this is a favorite question to be asked on exams that students really get confused by. So the keyword is everywhere. So let's say I have, a hash defined pi is 3.14 because I don't want to use underscore pi for some reason, right? If I do, let's say I want to print out my constant. So I'm going to say pi is equal to all right, so here's my print statement. I want to see what is the value of this constant. So I'm printing it out right here. So what is it going to print out? What's going to print out 3.14, right? So it did substitute in properly here, right? But we also have pi right here. It did not substitute in 3.14. It just kept the text pi because it was between double quotes. So therefore, B is going to be false, right? In most places it will substitute, but inside double quotes, for example, it will not. If this was true, you would see something like 3.14 colon 3.14. C, the ability to include additional libraries is a preprocessor directive that permits access to additional functions and constants within a program. This is going to be true. So if you want to use m underscore pi, you import math.h. If you want to use those random number generator functions, rand, srand, you import standard library stdlib.h. Right? And so when you do that hash include, it's really just saying go find this file and take all the code within and substitute it in wherever it's used. So you don't have to recreate the pow function, the square root, anything like that. Printf. So C is going to be true. Then moving on to questions 33 and 34. So given a and b are integer variables, both are greater than 0, and a is less than b. What is the range of values possible as a result of the expression b mod a? So a and b are greater than 0. A is less than b. So we have b mod a. So I'm going to rewrite this as b is greater than a, because that's the way I'm going to write this expression down here. So remember that anytime we do modulus, right, it's basically asking what's the remainder. And so in this case, if b is greater than a, we know that the remainder is going to be, probably a lot smaller than b, but it's going to have to do with our groupings. So I would think of it like this. Let's say our a is going to be 5. So b can be 5, 6, 7. So 5 from 5 to 10. B mod a, well 5 mod 5. We know that's not possible because b and a are equal. 6 mod 5 is going to be 1. 7 mod 5 is going to be 2. 8 mod 5 is going to be 3. 9 mod 5 is going to be 4. 10 mod 5 is going to be 0, because 10 is evenly divisible by 5. So, well, it's certainly possible that I could have just picked bad numbers that don't represent the overall behavior, right? I'm going to probably assume that I did choose a good set of numbers. And I can see from this pattern that the maximum value is 4 and a is 5. So the minimum value is 0, which we can see right here. And that would be the case if b was allowed to be 5. 5 mod 5 is also 0. And the maximum value is a minus 1. So if we continue this off to infinity, you would see a cycle of 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. And that's a very powerful behavior. Question 34. Which of these statements about the main function since the introduction of UDFs is true? A. Simple tasks such as input and output are permitted to be retained in the main function so that we don't make our program too long, doesn't take too long to write, anything like that. But this is going to be false, right? It is the expectation of this course that all printf and scanf is contained inside other functions, essentially all your input and output, to organize your code and to allow for reuse. Even if you don't call those functions multiple times in your code, it helps make your code easier to edit in the future for new problems, and maybe you will reuse those functions, calling them multiple times in the future. Beyond that, it's also expected that you have one input per function, or one type of data that you're asking for. So A is going to be false. B, the control of the program always returns from the called function to the main function. Keyword here is the main function. So most of the time B is true because most of the time we want to make our calls to UDFs from the main function, right? We want to organize our code such that the main function kind of orchestrates all the tasks going on. But sometimes we do have UDFs call on UDFs if it's a supporting task. Maybe we just want to get a unit conversion, we want to check if it's a leap year, something like that. Something very small is necessary in another function. And so we do have a UDF calling a UDF. There, in cases like that, right, the control is always going to return to whatever function called that UDF. So in that case, it would go back to the UDF that called it, which is not the main function. So B is going to be false. C, the main function is to coordinate the function calls and to establish the data needs of a program. It's kind of what I just said, but this is going to be true. So your main function should say, here's the order of tasks I want to do. Here's all the variables, the types of data that need to store those values in between. So if I'm going to prompt for a height that's an integer, I need to create an integer variable in main, call my input function, and then I'm going to pass that integer off to a different output function or calculation later on. So C is going to be true, 34.